set of subsequences. What is a subsequence? Subsequence is a sequence, but which is extracted from a given sequence. Roughly speaking, by deleting some or none entries of the given sequence. And the first thing that we talked about subsequence is that if a sequence is convergent, then all its subsequences are also convergent. Subsequences are convergent, and not only convergent, they converge, all subsequences converge to the same limit. All subsequences are convergent and converge to the same limit, and converges to the same limit. So this is one of the property that we had discussed about convergent sequences, and they are subsequences. And the second thing that we also saw yesterday is that in case your sequence is not convergent, then what can be said is the following, are converse of this statement, you may say, that says that if two subsequences of a given sequence converge to different limits, then the given sequence cannot be a convergent sequence in view of the first. Then the given sequence cannot converge in, that is, that sequence is a divergent sequence, cannot converge. That's it. So, and the example to justify this statement was that I gave you is that if you consider this sequence, this is a divergent sequence, but it has convergent subsequence. The first thing that now we will that I will state a result for you, which states that which is a kind of converse to this statement one that I stated there. It states that if suppose you have xn is a given sequence, and x is any real number, x is some real number, and all subsequences of the given sequence xn are convergent, and they all converge to this real number x. See, note the difference. The difference is that here I'm taking all subsequences must be convergent, and they all must converge to the same value. None of these two subsequences have a different limit. All subsequences must be convergent, first thing, and the other that they all must converge to the same value. Then the sequence itself is convergent. Xn itself is convergent. and converges to x and converges to x. So this is the converse of this. That means using subsequences, the convergence is to say that all subsequences need to be convergent and they all must converge to the same limit. If there exist two sequences which converge to the two different limits, then that will not be a sufficient thing to say that your sequence xn is a convergent. The sufficient hypothesis is that your sequences, all subsequences must converge to the same limit. So that's all about subsequences, convergence, and the convergence of a sequence. Now next, as we saw that there are sequences which are not convergent, but they have convergent subsequences. Now the question is, we want to characterize, we want to know that what are the sequences which have convergent subsequences? What are the sequences which have a convergent subsequences? And then we have a very well-known theorem which will tell us about class of sequences which will all definitely have a convergent subsequences. And this theorem is also known as Bolzano-Wierstrass theorem for sequences. Bolzano-Wierstrass, we have done this statement of this theorem for sets in unit chapter 1. So we will do it here now in for sequences also. This Bolzano-Weierstrass theorem version for sequences. And what it says that it says in a very simple language that a bounded sequence has a convergent subsequence. As a convergent subsequence. This is it. Okay. So uh, this is another relation between a bounded and a convergent subsequence. One way relation is that a convergent sequence is always a bounded, but now we can say with definiteness that maybe a bounded sequence is not convergent, as can be seen that I'm just repeating again the same example, that look at this sequence. This is bounded, this is bounded but not convergent. So Bolzano-Weierstrass theorem doesn't assert that the bounded sequence is convergent. It only says that bounded sequence will have a convergent subsequence. It will definitely have a subsequence, at least a one subsequence, which will be a convergent subsequence. Let us see how it is, how it can be proved. It's a very simple proof, and for the proof we require a result that I will be now calling it as a lemma. This lemma says that a sequence contains a monotone sequence. Every sequence contains a monotone sequence. Let us every sequence contains a monotone increasing subsequence. Increasing, this is the important thing that will help us to write the proof of the Bolzano-Weierstrass theorem. That whatever sequence you take, you will always get a subsequence of that sequence, which will be monotone, which will be a increasing sequence, which will be an increasing sequence. Similarly, you can also get a decreasing sequence, but I'm just stating it because I will take only monotone increasing sequence. So let us write the proof of Bolzanovastra's theorem. Very short proof. Bolzanovastra's theorem. What is the statement of Bolzanovastra's theorem? It says that a bounded sequence will have a convergent subsequence. So let us take a bounded sequence first. Let Xn be a bounded sequence. Be a bounded sequence. Then this is a sequence, so let's apply a lemma to this sequence. This lemma says that this sequence will have a subsequence which is monotone. Then by lemma, which I just stated above, uh, we can get a monotone increasing subsequence. Say let that subsequence be denoted by X and K of we can get a monotone subsequence of this. Now, since by hypothesis your sequence xn is bounded, so its subsequence will also be a bounded sequence. Now, since sequence xn is bounded, this is by hypothesis because we are dealing with bounded sequences now. Bounded, so the subsequence which is monotone x and k is also bounded. So what you have now about this subsequence, this bounded, this subsequence is monotone and this is bounded also. And if you remember what is a monotone convergence theorem, monotone convergence theorem says that, recall monotone convergence theorem, monotone convergence theorem says that if a sequence is bounded and monotone, then it is always convergent. So here we have this subsequence x and k, which is monotone, and now it is bounded also. Hence, by monotone convergence theorem, this sequence subsequence x and k is convergent. So what we have now, we had a bounded sequence xn, and finally, through using this lemma and hypothesis, we've been able to show that this sequence has a monotone and bounded sequence x and k. And then by the application of monotone convergence theorem, we see that this subsequence is a convergent sequence. And this is what we had to prove, that a bounded sequence has a convergent subsequence. And this completes the proof of theorem. Is it okay?
Yes, sir.
Do you have any? Good. So now this Bolzano-Weierstrass theorem opens several other questions. The first thing is that let us take, suppose you have a bounded sequence, xn is bounded. This is a bounded sequence. The first thing is that then by Bolzano-Weierstrass theorem for sequences, it says that it has convergent subsequence, at least subsequence, or it might have many subsequences. Yeah, let me write. It has a convergent subsequence. This is the guarantee now. First part is guaranteed. It will definitely have a convergent subsequence. But sometime, what happens that a sequence may have, a sequence may have more convergent subsequences. This is also possible, convergent subsequences, because if the sequence itself is convergent, then all its subsequences will be convergent. But if the sequence is not convergent, then clearly all its subsequences may not be convergent. But without being a convergent, still it can have many convergent subsequences. And the other thing is that they might have different limits. They might have different limits. So what I'm going to call then, so may have more convergent subsequences, and uh, they might have different limits. For example, I'm going to take again the same sequence. I'm again going to take you to the same example. Let us take this example sequence xn equals to minus 1 power n. Now see, let me take a subsequence. Let me take two subsequences. One subsequence I'm going to take x to n, and in x to n I will have minus 1 to power 2n, which is nothing but which is a constant sequence, 1 1 1 so on. And the other subsequence I'm going to take of this sequence is x 2n minus 1. This is also a subsequence containing only the terms which are at odd positions. It is minus 1 to power 2n minus 1, and power being an odd number means you have only constant sequence minus 1 so on. So you see both these subsequences are constant subsequences, and constant sequences are always convergent. Then both these sequences sequences are convergent, but mm, the sequence do not have only two subsequences. I'm just taking two particular subsequences through which I can demonstrate to you that they have different limits, and what will be known as what we are going to call those limits. Sequences are convergent and have different limits. Different limits. For the limit of a first subsequence is 1, because the constant sequence 1, it will converge to 1, and the limit of the second sequence, which is again a constant subsequence, and its limit is minus 1. So they have different limits, 1 and minus 1 respectively. So these 1 and minus 1 are limits. They are not limits of xn, because xn is not convergent, but these are limits of its subsequences, two particular subsequences, and we give them some special name. These limits are called subsequential limits. This is called subsequential limits. So a sequence will have another kind of limits, that they are subsequential limits. So what is a subsequential limit? Subsequential limit is a limit of a subsequence of a given sequence, if it exists. It is not necessarily that it will always have a subsequential limit. Sometimes it might not have subsequential limit. So next thing that you might note, that a sequence may or may not have may not have subsequential limit may not have subsequential limit. For example, let us take the sequence xn equals to n square. Because this sequence is unbounded, every subsequence of this sequence is going to be unbounded and going to infinity. So none of its subsequence is going to be a convergent. So this has no subsequential limit. And another name that is given to this subsequential limit, it's you have to keep this in mind. Subsequential limit of a sequence, say it is a sequence xn, subsequential limit of a sequence xn is also known as limit point of given sequence xn. See, I'm not saying there is a limit of a sequence, I'm saying it is a limit point of xn. Limit of a sequence is always unique, but as can be seen that limit points of a sequence may be more than one. For example, this given sequence 1 and -1 has more than two limit points. It has two limit points. You can say two limit points. So now with these new terminology, with these new notations, new names, Bolzano-Weierstrass theorem can be restated as restatement of Bolzano-Weierstrass theorem. And what is that? Restatement of Bolzano-Weierstrass theorem states that I had stated it that bounded sequence has a convergent subsequence, and now limit of a convergent subsequence is called the limit point of a sequence. So we may say that a bounded sequence has a limit point, has a limit point. That's it. It has a limit. But I'm not saying that it has a limit. Okay. One thing is this. The next thing is that since now we see that a sequence may have more than one limit points, and let us take a bounded sequence for the time. We are considering only bounded sequences. Let xn be a bounded sequence, and now it is a bounded sequence, and by Bolzano-Weierstrass theorem it is definite that it will have at least one subsequential limit, or you call it is a limit point. And let me take a set in which I'm going to keep all those limits, those limit points in a set S, and let S denote the limit points, denotes the set of all limit points of sequence xn. Now I have taken xn to be a bounded sequence, and so this set S is also again a bounded set because sequence xn is bounded. Since xn is bounded, it is bounded, so set S is also bounded. And once you know that this set S is bounded, you know that bounded set has infimum and it has supremum also. So S has its supremum as well as infimum. So it has both things now, supremum as well as infimum. And these supremum and infimum are given some special name. We define, it is now clear that this set will have supremum and infimum, or you can say there are bounded limit points of a bounded sequence will have their supremum and infimum. So this supremum is denoted as limit sup of xn. This is nothing but this is supremum of this set S. That means supremum of all limit points, supremum of all limit points, and limit I n f of xn and tending to infinity and tending to infinity. This is known as infimum of S. And these limits, they have alternate notations also. This limit superior, limit sup has this notation also, and xn bar above and tends to infinity, and this infimum of this set has another notation also and tends to infinity xn. And how it is, how these are pronounced. This first one is read as limit superior. This is known as limit superior, and this second one is read as limit inferior. So limit inferior and limit superior are limit points of a sequence, and but what limit points they are? They are smallest and the largest limit points of the given sequence. That has to be proved. I haven't told you that we haven't proved it yet that these are limit points, but they are going to be limit points. These are limit points of the given sequence xn. I have you may see your notes there. Then your notes today's lecture contains 7 exercises, 7 to 8 exercises that and they are not actually exercises. They are kind of construction to this concept of limit superior and limit inferior, and that is assignment work for you. You have to complete that assignment that I will post there. So the another immediate thing about limit superior and inferior that you can see, I'm just going to give 2 examples. The first thing, the first example, I'm going to give you this -1 to power n, as can be seen that in this case, the set of all limit points of this sequence contains only -1 and 1. These two are the only limit points of this sequence. Hence, if this is bounded and clearly its infimum is -1 and its supremum is 1, hence limit superior of this sequence -1 to power n, limit superior is 1 and its limit inferior is -1. Okay, and the second thing, if I take a sequence xn which is convergent, what about limit inferior and limit superior of that sequence? If it is convergent, what it says that how many limit points this sequence will have. Since it is a convergent sequence, it will have only one limit point, because all subsequences in this case are convergent and all subsequences are converging to a same point. So it will have only one subsequential limit. Then xn then S, which is a set of all limits. S consists of only one point x, which is a limit, where x is a limit of this sequence because it is a convergent. Because all subsequences are going to be convergent and they all are going to converge x, so it will have only one limit point. So in this case, this sequence has only one limit point, that is the limit of this sequence. And in this case, clearly this is a singleton set, and single is supremum and infimum of this singleton set is the is element singleton itself. So in this case, limit superior of this sequence is x, and this is this limit inferior also. This is the limit inferior also. So in case of convergent sequence, you got to see that limit inferior and limit superior are equivalent, and you have to I have kept this as a home assignment for you, that not only in convergent sequences limit superior and limit inferior are equal. In case wherever you have these two limits equal, then the sequence is going to be a convergent. This is the convergence criteria for sequences also, in terms of limit superior and limit inferior, and other equivalent definitions are also there, and you have to complete those uh, home assignments.